Today I will discuss the signal flow graph. The signal flow graph is another graphical representation of the control system. Signal flow graph is another graphical representation of the control system. It is consist of a network graph in which the node represent the system variable. The nodes are connected by directed branch. In other words, a single flow graph is one which the variables are represented by the node of the graph, while the relation between the variables are represented by the branch connecting node or a connecting node. We take an example, the signal flow graph represented from the equation from the signal flow represented from the equation y is equal to ax. Y is the output of the system and x is the input of the system and end is the transfer function. The equivalent block diagram represented x is input, the transfer function m, their output is y. Then is convert to the block diagram, the x is input, the output is y and m is in block. The signal flow graph from the diagram. Consider the block diagram represent of the system. The diagram represented of the system, it is a whole on the block diagram the diagram. Here the x1, here the x1 is a input, g is the transfer function, it is a summing point, and g2 is another transfer function, is the takeoff point, is a transfer function, is another summing point, the takeoff point is another transfer function, and their output is x5. Here the input terminal, output terminal, node, summing point are denoted by node. x1 is a node, x2 is a node, the summing point is represented by the node is x2, and the takeoff point x3 is another node, and here the summing point and takeoff point, they are both is a one node because the no transfer function between the no transfer function between the summing point and takeoff point there, because the no block diagram it is a one node, the node is x4, the g5 is the transfer function and x5 is a node. The equivalent signal flow graph is represented so in below. Its equivalent signal flow graph representation so in below. So in below, x1 is a node, the node is input x1, the transfer function is g1, and x2 is another node, and x3 is equivalent to takeoff point, and g3 is the transfer function, here the transfer function g3, and total function is a one node is x4, and the transfer function is g5, the output is equivalent to x5. x3 and x2 is connected through the feedback element is h2. It is equivalent to the path of node x2. The x3 output is connected to the input x2 through the feedback element is h2. The block diagram and signal flow graph is equivalent. This portion and this portion is equivalent or equal. Here the summing point and takeoff point, they are between a no transfer function, no g, no transfer function. There is a self loop. It's called the self loop because there has a no any transfer function. The transfer function, the feedback element is h1 and g4. The transfer function, the output is x5. It is a signal flow graph of the block diagram. Next point is signal flow graph terminology. The next point is signal flow graph, signal flow graph terminology. The first terminology, the different term used in signal flow graph are explained. Number one is node. Number one is node. It is a system variable which is equal to the sum of all incoming signal at the node. The outgoing signal from the node and do not affect the value of the node variable. Here the node x1, x2, x3, x4 and x5 all the are node. Here the node is x1, x2, x3, x4 and x5. There are node. One node. I told you the first the equation y is equal to mx. Y is the output, m is the function and x is the input. Therefore x2 is equal to x2 is equal to x1 into g1. x1, therefore x2 is equal to x1 into g1 plus x2, the x2 is x1 is the input, x2 is the output. The input, the another input is h2. The output is a feedback element. Therefore x2 is equal to x1 into g1 plus x3 into h2. x3 into h2. The x2 is equal to x1 into g1 plus x3 into h2. The x2 is the output and the x1 is the input, another is the input. Therefore is the x2 is equal to x1 plus g1 is x3 to x2. Similarly the value of x4 is equal to x3 g3 plus h1 into x4. The next point is branch. A branch is the direct line between the node. Branch is a direct line between the node. Here the x1 is a node, x2 is a node, x3, x4 and x5 is a node. The direct line between the node, the x1 and x2, the direct line between the node. This line is called branch. This line is called branch. This line is branch and this line also a branch. The branch is the node. Branch is a direct line between the node. Third point is transmittance. Transmittance is a gain between node or branch gain. Transmittance is a gain between node or branch gain. Such the gain are expressed in terms of the branch function. Transmittance is a gain between the node or branch. G1 is the transmission, G2, G3 and G4 are the transmission. Fourth point is the input node or source node. Input node or source node. Input node or source node. It is a node which has only the outgoing branch. It is a node which has only outgoing branch. For example, the node x1. The node x1 is an input node or source node. The next terminology, point 5, the chain node or mixed node. Chain node oblique mixed node. Chain node like mixed node. Chain node or mixed node, it is a node which has the both incoming and outgoing branch. It is a node which has the both incoming and outgoing in a branch. The x2, x3 and x4 have the both incoming and outgoing signal. Hence they are called as chain node. x2, x3, x4. x2, x3 and x4, the three node are the mixed chain or chain node. A mixed node or chain node because there has a two terminal input and output. It is a input and is a output. Their output x3 there is a input and their output, here the input, here the output. The x2 and x3 and x4 is called the chain node or mixed node because there has a both input and output. 6, forward path. Forward path, it is a path from input node to the output node. Input node, it is a path from the input node to the output node. The forward path is x1 to x2, x3, x4 and x5. Total number of node 5 and it's called the forward path. The path from input to output is called the forward path. Number 7, closed loop. Number 7 is closed loop. This is a loop which starts from a particular node and end at the same node. This loop which start from a particular node and end of the same node. For example, x2, x3 and x2, x2, x3 and x2. It is a closed loop. x2, the node x2, x3, x2 starting point x2 and end point x3. From the x3 to again x2, it's called the closed loop. From x2 to x3 again x2 is called the closed loop. Number 8, self loop. Self loop. Self loop, it is also start from a node and end at the same node. It start from a node and end at the same node having only one branch is called the self loop. Self loop. They start from the node x4 and end to the node x4. There has a no branch is called the self loop. There has a no branch and the starting point and end point are same is called the self loop. So this is a signal flow. This is a signal flow graph. This convert their work. Our work is this block diagram is convert to the this signal flow graph. That's enough.